Hello all, welcome to the Countingwell exam prep live session. Before we start the session, let me motivate you a little. Always remember that success is not accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing or learning to do. We know that exams are around the corner, and the two greatest factors of all successful exam results are revision and practice. Remember that practice doesn't make you perfect but helps you to perform better. Planning beforehand allows plenty of time for you for your revision. And so, we are here to shoo away your exam fear and help you revise your concepts before it's too late. So, stay tuned to the session and build up the confidence to face your exam. In this session, I will take you through two chapters, rational numbers and playing with numbers from class 8. Let us see some basics of the chapter rational numbers. Rational numbers are nothing but numbers of the form a by b, where a and b are numbers such that b is non-zero. Now let us see the operation addition on rational numbers. Rational numbers with same denominator and rational numbers with different denominators. When we are taking the addition of two rational numbers having same denominator, we add the respective denominator. For example, here we are having rational numbers 13 by 6 and 11 by 6. Note that they have same denominator 6. While taking the addition of these two rational numbers, the denominator is kept as it is and we add the numerators. So here we add 13 and 11, which will give you 24. So addition of 13 by 6 and 11 by 6 is 24 by 6. Let us see how to add rational numbers with different denominators. For example, if you want to add 1 by 2 and 3 by 4, here note that they have different denominators, that is 2 and 4. In this case, we find the LCM of the denominators, which are 2 and 4. So LCM of 2 and 4 is 4. That's why what we are going to do is, for the first rational number 1 by 2, to make the denominator 4, we multiply it by 2 and same we do to the numerator. So we have here 1 into 2 upon 2 into 2, which is equal to 2 by 4. Similarly, for the second rational number, which is 3 by 4, we have already 4 in the denominator. So no need to multiply number other than 1. Or we can keep it as it is. So 3 by 4 will be as it is. Now we have two rational numbers with same denominator, that is 4. That's why we add their respective numerators. So we have 1 by 2 plus 3 by 4 equals to 2 plus 3 by 4, which is 5 by 4. Now let us see subtraction in case of rational numbers. We will see here example of rational numbers with different denominators. So here we are going to subtract 1 by 2 from 3 by 4. So we find the LCM of 2 and 4 since the denominators are different, that is 2 and 4. We know the LCM of 2 and 4 is 4. That's why 3 by 4 will be as it is. Whereas for 1 by 2, we will multiply numerator and denominator both by 2. So you will get 2 by 4. Now we will subtract by rewriting 1 by 2 as 2 by 4. So here we'll take the subtraction of numerators, that is 3 minus 2 upon the denominator 4. This is equal to 1 by 4. Now let us see how to do multiplication for rational numbers. Here we are going to multiply a rational number by an integer. For example, we can take 13 by 6 and minus 3. Multiplication of rational number 13 by 6 and a integer minus 3 is shown here. Here we are going to multiply minus 3 to the numerator of the rational number, which is 13. So we have 13 into minus 3 divided by 6. We carry the minus sign as it is and we do the product 13 and 3. So we have minus 39 by 6. We write this rational number into its simplest form. So we have minus 13 by 2. We write this as mixed number. So we divide 13 by 2. So we have 2 6 are 12. We know 12 plus 1 is 13. So we can write this product as minus 6 1 by 2. Now to multiply a rational number by a rational number, for example, we take here minus 9 by 4 and minus 3 by 5. We take their product. We multiply the numerators and we multiply the denominators of both the rational numbers. So here we have 9 3s are 27 divided by 5 4s are 20. So in this way, we have seen how to multiply a rational number by an integer, also multiplying two rational numbers. Now let us see some of the properties of rational numbers. In case of addition, we have closure property, commutative property, associative property, additive identity, and additive inverse. So if we take any three rational numbers a, b, c, the closure property says that for any three rational numbers a, b, c, a plus b is equals to c. That means the sum of two rational numbers is again a rational number. So if you have 1 by 2 plus 1 by 2, you will get 1. 1 can be written as 1 upon 1. So again, you will get a rational number, that is 1. For commutative property, we have a plus b equals to b plus a. That means the resulting sum of two rational numbers, if we change the order, is same. That is 1 by 2 plus 3 by 4 is same as adding 3 by 4 and 1 by 2. Now let us see associative property for rational numbers. For any three rational numbers a, b, c, a plus b plus c is equal to a plus b plus c. So no matter which two numbers you are adding first, the resulting sum will be same. So if you add b and c first and then add a to it, it is same as adding a and b first and then adding it to c. Let us see what is additive identity. Here the identity is written. That means if you add a number to a rational number, then you will get the same rational number. And that number is nothing here but 0. So 0 is nothing but the additive identity for rational numbers. So if you add 0 to any rational number, for example, adding 0 to 1 by 2, you will get again 1 by 2. That's why 0 is called the additive identity. Remember that for any rational number, the additive identity is fixed, which is 0. Let us see what is additive inverse of rational numbers. If you have any rational number, say a, then its additive inverse is nothing but a number which when added to that number gives you 0. So if you take a number, a rational number, for example 1 by 2, if you add minus 1 by 2 to it, you will get the resulting sum as 0. So for every rational number, there is a unique additive inverse. So what is the additive inverse of 0? My question is whether 0 is a rational number. Yes, 0 can be written as 0 by 1. So it is a rational number. So the additive identity for 0 is again 0. Whereas the additive inverse for 0 is again 0. Let us see the properties for subtraction. For any rational numbers a, b and c, we have closure property, commutative property, associative property. Let us see which of these properties holds for subtraction. Note that the subtraction of two rational numbers is again a rational number. So if you take any two rational numbers and take its subtraction, you will get again a rational number. But the commutative property doesn't hold true for rational numbers. So 1 by 4 minus 1 by 2 is not same as 1 by 2 minus 1 by 4. It's when you change the order of subtracting the two rational numbers, we will not get the subtraction or the resulting subtraction as it is. Now for associative property, since commutative property is not true for subtraction of rational numbers, the associative property is also not true, because subtracting b minus c from a is not same as subtracting c from a minus b. I hope this property is clear for all. Now let us see property for multiplication of rational numbers. Again, if we have any three rational numbers a, b, c, the closure property says that the product of two rational numbers a and b is again a rational number. So if you take the product of a and b, you will get a resulting number which is again a rational number, which is c. Now what is commutative property for multiplication of rational numbers? No matter in which order you multiply two rational numbers, the resulting product will be same. So multiplying 1 by 4 to 1 by 2 is same as multiplying 1 by 2 to 1 by 4. For associative property, we have multiplying a and b and taking the product with c is same as first multiplying b and c and taking its product with a. Now let us say what is multiplicative identity for rational numbers. We had additive identity for rational numbers. In similar way, we have multiplicative identity for rational numbers. Multiplicative identity of rational numbers is nothing but the number which when multiplied with a rational number gives you the same rational number. So in this case, that number is 1. Here 1 is called the multiplicative identity, which is fixed for every rational number. So no matter how big or large is the rational number or whatever rational number you take, if you multiply that number with 1, you will get the same number. So 1 by 2 multiplied by 1 is same as 1 multiplied by 1 by 2, which is 1 by 2. Now let us see what is the multiplicative inverse of any rational number a. The multiplicative inverse is nothing but a number which when multiplied with the rational number, you will get the resulting product as 1. So here, if you take a rational number 1 by 2, its multiplicative inverse will be 2. As 1 by 2 into 2, you will get the resulting product as 1. So every rational number has a unique multiplicative inverse. What will be the multiplicative inverse of 0? Note that we cannot have a multiplicative inverse of 0 because 0 multiplied to any number cannot be equal to 1. Now let us see distributive property of multiplication over addition and subtraction. So A multiplied by B plus C. So we are multiplying a rational number with the sum of two rational numbers. So it is nothing but A multiplied by B plus A multiplied to C. Here note that the multiplication is distributed over the addition. Similarly, we can multiply a rational number to the subtraction or to the difference of two rational numbers B minus C in this case. So we have A into B minus A into C. Let us see whether these properties hold true for division. The closure property does not hold good for division of rational numbers. So division of two rational numbers cannot be a rational number always. Similarly, for commutative property, the order is important while dividing the rational numbers. So A divided B is not equal to B divided by A. Associative properties also does not hold good for division of rational numbers. You can find examples which prove these properties are not holding good. Let us see number line. We can represent rational numbers on number line. Note that the positive rational numbers always lie to the right side of 0 and the negative rational numbers always lie to the left of 0 on a horizontal number line. In case if you take a vertical number line, the positive rational numbers lie to the above of 0 and the negative rational numbers lie to the below of the number 0. Now, representing rational number on number line is as simple as shown here. If you want to represent, for example, a rational number 2 by 3, you'll first draw a number line and divide each unit into 3 equal parts. Here, unit means the space between the distance between the number 0 and 1. So this line is divided into 3 equal parts. Or we can say the line segment between 0 and 1 is divided into 3 equal parts. And since the denominator is 3 and the numerator is 2, we will mark the required rational number at the second part. So this will be 2 by 3. Now let us find rational numbers between two rational numbers. First, we will see how to find a rational number between two rational numbers. Here, if we have two rational numbers x and y, then the mean of these two rational numbers is again a rational number. For example, to find the mean of 2 by 5 and minus 1 by 3, we take its sum and divide by 2. So the rational numbers 2 by 5 minus 1 by 3, adding the numbers, we get 1 by 15 and dividing it by 2, we will get 1 by 30. So 1 by 30 will lie between 2 by 5 and minus 1 by 3. So to find a rational number between two rational numbers, we will take the mean of the two rational numbers. Taking a mean of two rational numbers is nothing but taking their sum and dividing it by 2. Let us see how to find more rational numbers or two rational numbers, more than two rational numbers between the given two rational numbers. For that, we will first find the mean of the given rational numbers. That mean will definitely lie between the given rational numbers. Then what we are going to do next is we will find the mean of the first rational number and the mean obtained in the step 1 again. We will repeat this procedure to find the remaining rational numbers. For example, here we have two rational numbers 3 by 2 and minus 5 by 3. First, we will find mean of these two rational numbers. Here in this case, the mean is minus 1 by 12. Again, we will take the first given rational number, which is 3 by 2, and the mean obtained of the given rational numbers, which is minus 1 by 12. Taking mean means taking the sum of the two numbers and dividing it by 2. Because there are two numbers, so we are dividing it by 2. Here we'll get 17 by 12 multiplied by 1 by 2, which is equal to 17 by 24. So in this way, we have obtained two rational numbers lying between 3 by 2 and minus 5 by 3. Now let us start revising playing with numbers. Note that any two-digit number AB can be written as 10A plus B, whereas any three-digit number ABC can be written as ABC equal to 100A plus 10B plus C. Let us see some number patterns. The sum of a two-digit number and its reverse is a multiple of 11. For example, if you take a two-digit number 45 and take its reverse. Taking its reverse means interchanging the digits. So the reverse of 45 is nothing but 54. If you take the sum of these two numbers, you will get 99, which is a multiple of 11. You can check this for any two-digit number. For example, you can take 22, 23, 24. The reverse of 23 is 32. Adding both the numbers, you will get 55. So again, 55 is a multiple of 11. If you take a number 20, its reverse will be 2. Adding 20 and 2, you will get 22. 22 is again a multiple of 11. Let us see one more property for the difference of two-digit number and its in reverse. If you take any two-digit number, for example, here we take 72, its reverse will be 27. If you subtract them, you will get 45, and 45 is a multiple of 9. That's why any difference of two-digit number and its reverse is a multiple of 9. Let us see one more pattern, which is the difference of a three-digit number and its reverse. Take any three-digit number. Here we take 842. Its reverse will be 248. You have to write the digits from the extreme right and write it from extreme left. In this way, you will get the reverse of any three-digit number. So here you get 594 as a difference, which is a multiple of 99. For the sum of three-digit numbers A, B, C, B, C, A and C, A, B, you will get it divisible by 37. For example, if you have 123, 231 and 312, you will get 666. 666 is a multiple of 37. You have to take care for the sum of three-digit numbers here. We will also see what are the common mistakes students do for this number pattern. Let us see some divisibility rules for the numbers one by one. We have divisibility rule for 2. A number is divisible by 2 if one's digit is 0, 2, 4, 6 or 8. So any number ending with 0, 2, 4, 6 or 8 will be divisible by 2. For example, 324, 558, 7000. Let us see divisibility rule for number 3. A number is divisible by 3 if the sum of its digits is divisible by 3. So if you take any number and take the sum of its digits, here in this case we have 324. If you take the sum of the digits 3, 2 and 4, you will get 9. Since 9 is divisible by 3, so the given number which is 324 is also divisible by 3. Let us see divisibility rule for 5. Any number ending with 0 or 5 is divisible by 5. So if you have numbers 325, 440, note that the ones digit is either 0 or 5. So they are divisible by 5. Let us see divisibility rule for 9. If the sum of the digits is divisible by 9, then the number is divisible by 9. For example, let us take a number 981 and take the addition of the digits 981. You will get 18. As 18 is divisible by 9, so 981 is also divisible by 9. Let us see divisibility by 10. If one's digit is 0, then that number is divisible by 10. So here, for example, we have 327,000, 1,000, 10. These are all divisible by 10. Let us see some of the tricks for these 2 chapters. First is representing rational numbers on a number line. So how to represent rational numbers like 1 by 5, minus 3 by 7, 2 by 7, etc. We will see in this trick. The trick is that the denominator of any given rational number indicates how many parts each unit on the number line should be divided into. Then we have to draw a number line and each unit divided into equal parts as indicated by the denominator. Next, we have to locate and mark the required rational number. For example, if you want to locate minus 5 by 6 on a number line, we will first draw the integer number line. Note that the denominator is 6 here, so we divide each unit on the line into 6 equal parts. So note that how the each unit is divided into 6 equal parts, or we have done here 6 equal divisions. Now, since the rational number is negative, that is minus 5 by 6, we have to locate the number to the left side of 0. So we will take 5 steps to the left side of 0. 1, 2, 3, 4, 5. So here we have minus 5 by 6, which is the required rational number. So 6 is the number of parts the unit is divided, and 5, which is the numerator, is the number of steps we have to take on the number line. Applying distributive property is not less than a trick. So while applying the distributive property, you should multiply the term outside the brackets with each term within the bracket. So it's not like you're multiplying minus 2 by 7 to 7 by 12 only. You have to multiply it with one more rational number here, minus 5 by 3. So the term outside the bracket should be multiplied with each and every term within the bracket. So here we have two terms inside the bracket with addition. Remember, you have to multiply the term outside the bracket with each term within the brackets. So we multiply minus 2 by 7, first with 7 by 12. We will carry over this plus sign and then we will multiply minus 2 by 7 with minus 5 by 3. So we have minus 1 by 6 plus minus plus 10 by 21. So we have minus 7 by 42 plus 20 by 42. And in this way we have 13 by 42. Also, while simplifying expressions with rational numbers, you should always follow BODMAS rule. BODMAS is nothing but bracket of division, multiplication, addition and subtraction. For example, if you want to simplify the given expression 4 by 5 into 1 by 2 minus 1 by 5, based on BODMAS rule, first we must perform multiplication. So first we have to multiply 4 by 5 and 1 by 2. So we will get 2 by 5 and then we are going to do the subtraction. We will get 1 by 5. Now let us see some of the tricks for the chapter playing with numbers. The only trick to make the calculation faster is to learn and understand all the divisibility rules for 2, 3, 4, 5, 6, 8, 9, 10 and 11. Numbers ending with 0, 2, 4, 6 or 8 in are the numbers divisible by 2. If the sum of digits of a number is divisible by 3, then the number is divisible by 3 and so on. Next, we have to take care while we are writing number and its reverse. So while solving questions on a number and its reverse, remember that if the number with digits a and b is 10a plus b, then its reverse is 10b plus a. So while writing any number, so if you have a number 32, 32 can be written as 10 into 3 plus 2. So what will be the reverse of 32? You will have 23. To write 23, you can write 2 into or 10 into 2 plus 3. So 10a plus b has its reverse 10b plus a. Now, in exams, we will have questions where you have to find the value of letters. So while solving such questions, do not forget that the carryover from the previous step is to be added. For example, in this case, we have the value of a is 9. To find b, we should have b plus 1 equals to 3, hence b equals to 1. So once you know the value of a is 9 and 9 plus 9 is 18. So we carry over 1 from the previous step. Now a is 9, so 9 plus 9 is 18 and plus we add this 1. So again we'll get a 9. We carry over 1 here. So we have b plus 1 equals to 3. That's why we have b equals to 1. Now let us see some common mistakes that students do while solving examples. Let us see for the chapter rational numbers first. Operations with rational number will follow rules of integers and fractions only. So whatever rules we are following for the simplifying expressions or equations for integers and fractions, Same set of rules we will follow for rational numbers. So when we simplify rational numbers, for example, to simplify the expression given here, 2 by 3 plus minus 3 by 4 multiplied to the product of 8 by 9 and 6 by 11. So here we will solve the square bracket first. So this will be 16 by 33. We will follow the rules of fractions here. And then we are going to do the product of minus 3 by 4 and 16 by 33, which is minus 4 by 11. Then we are going to subtract these numbers. So we will first find the LCM of the denominators, which is 33. Then we have in the numerator 22 minus 12. This is by following the rules of fractions. That is what we have done here. The fractions have different denominators. So we have found the LCM and then we have done the operation. So the resulting answer is 10 by 33. One more mistake the students do while applying distributive property is you should multiply the term outside the brackets with each term within the brackets. It is not the case that you have to multiply minus 2 by 5 to only to the first term. So students usually forget to multiply it with the second term as well. Remember that inside the bracket we will either have positive sign, that is plus sign, or minus sign, and outside the bracket we will be having product of some number, or we will be taking the product of a number with the sum of two numbers. So here we are applying distributive property. So multiply the term outside the brackets with each term. So for simplification, we have the final answer as 11 by 30. Playing with numbers, let us play with some numbers and take out our confusion between odd and prime numbers. Which of the following are prime numbers out of the set of numbers given here? The numbers given here are 2, 3, 4, 5, 7, 9, 13 and 16. Odd numbers are numbers which are not even. Prime numbers are the numbers having factors 1 and itself. So the prime numbers here are 2, 3, 5, 7 and 13. Note that the only factors of these numbers are 1 and the number itself. Many times the terms prime and odd numbers may cause confusion. So always remember that 2 is the only even prime number and all other prime numbers are odd. This doesn't mean that all odd numbers are prime numbers. Okay. But every prime number is odd except 2. For example, 9 is not a prime number since it has more than 2 factors, 1, 3 and 9. So for the better understanding, let us categorize these numbers as shown here. We can categorize numbers as odd prime, odd composite or even composite. The only even prime number is 2. That's why in that column and row, we have the number 2. Let us see how students get confused while writing the generalized form of a number. For example, if they have any 2-digit number represented by AB, always remember that AB is not A into B. It is just the representation of any number. For example, if we have a number 13, so 13 is represented as AB, where A is 1 and B is 3. We cannot write 13 as 1 into 3. That's why AB is not equal to A into B. Instead of A into B, AB is written as 10A plus B. So the generalized form of 63 is 10 into 6 plus 3, not 6 into 3. Similarly, for a 3-digit number, we can represent any 3-digit number by ABC, which is not equal to A into B into C. It can be written as ACB equal to, or here we have ABC equal to 100A plus 10B plus C. The sum of 3-digit numbers are 429, 942 and 249. Using digits 2, 4 and 9 is not divisible by 37. We have seen a trick where we are taking the sum of 3-digit numbers and the sum is divisible by 37. But can we take the orientation of these numbers randomly and take their sum so that we get a number divisible by 37? Let us see. Whenever we are forming 3-digit numbers using the given 3 digits, their sum will always be a multiple of 37 if we follow a rule as shown here. For example, if you want to form 3-digit numbers using given 3 digits 4 to 9, we will first take the number by shifting one digit to the left hand. So the resulting number will be 942. Next, the second number is taken by shifting the hundreds digit to the right hand. So we have 294. Note that the sum of 429, 942 and 294 is 1665, which is divisible by 37. But if you randomly do the orientation without following these rules, then you will not get the sum as divisible by 37. So if you take 429, the second number is as 942 and the third number as 249 instead of 294, then you will not get the sum divisible by 37. Next, let us see some exam tips. Practice a variety of questions from your NCERT textbooks, exemplar, other textbooks, and from previous year question papers. Also, you have to note down all the definitions and properties, and you have to glance at them before you are going to attend that test. You have to avoid calculation mistakes while you are using any patterns in numbers, or while you're finding the LCM of two denominators of two rational numbers, while you are adding them or subtracting them. You should always express the final answer or the rational number in the simplest form. Also, while solving word problems, write what is given in the question, what we must find, etc. This helps in identifying the right strategy or the right rule required for solving the given question. You should practice more and more questions on finding the value of letters. So this will help you to solve these types of puzzles fast and easy. You should be thorough with the divisibility rules to make your calculations simpler and easier. You should always read the given question carefully and understand it. Also, you have to check whether you have answered all the questions and parts of the question. I hope this session was helpful, and if you want to quickly revise the concepts, practice some extra sums, and also take a quick test, Countingwell exam prep kit is here. Countingwell exam prep kit lets you quickly glance through the major concepts of your chapter. You can also glance through solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks, common errors that you make, etc. Over 75,000 students trust Countingwell for their math learning. And even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can also download the app from the App Store or Play Store. Stay connected to our channel Countingwell and learn more tricks and tips and ways to avoid common mistakes. We will be revising the chapters integers and rational numbers from class 7 in our next live session tomorrow, that is on Wednesday at 6:30 p.m. Well, see you in the next session. Until then, keep learning, keep growing. Thank you.